Hi, everyone. Yeah, last talk before dinner. No pressure. I can feel the energy. So yeah, I'm Tiziano. I'm the engineering lead of Project Oak. I think you heard from a few of our colleagues today. And today I have two goals. I'll keep it short. I have two goals for this presentation. And it's about to tell you about content addressability, if you don't already know about it. It's a pretty cool concept. And I'm going to tell you about end and static space, which is some of my projects. But first, I have a task for you. I have a shopping list, so if you can help me go and do this shopping. Spoilers, this is a location-addressed shopping list. So you have to go to the supermarket, and then you get to the aisle number 3, and you go to the 4th shelf, and you get the second item from the left. And then, yeah, whatever, you can see the rest there. So yeah, what can go wrong with that, right? Imagine that you actually have to do this thing, right? I literally give you this list and tell you where to go and where to find the items, right? What can go wrong? 404, maybe you go there, the supermarket is closed, doesn't exist anymore. Or maybe it is open, but you go there and on the 4th shelf of the 3rd aisle, there is oil instead of the milk or whatever. Or maybe the items are there and you go and fetch a box of crackers, and instead of being like a nice square box, it's like all like broken and the stuff inside is not that good. And finally, if I give you this list and you go to a different supermarket, this list is completely useless, right? So, I mean, I know this is a silly example, but if you think about it, this is kind of like how most of the internet works today. If I give you a URL, if you really think about the pieces of the URL, right? It tells you how, like what protocol to use, which web server like to go to, and then the path inside the web server that you need to access a file, right? It's really how it works. And so, like, think about it like if I give you a list, I wouldn't give you that list. I would give you like the content of the things that I want you to go and find, and then you figure out which supermarket you want to go to and wherever they are in the supermarket, right? It doesn't really matter to the extent that I give you the list, right? But yet we seem to accept the previous model, the location address model, is fine for the internet, while this is a content address version. Has some advantages, right? So yeah, I'm going to tell you today a little bit about End, which is one of my sort of side projects. It's a Google project, but it's not an official Google product. So please talk to me before you actually take a dependency on it, if you ever consider that. Really, basically, the idea of End is just is a protocol that lets you resolve, like given a digest of whatever binary, it tells you where you might find the corresponding files over the internet giving you a bunch of HTTPs. I won't go into too much detail here. I don't have much time. I'm happy to talk more or take questions about exactly why it looks kind of weird like this. But you can imagine, basically, you have this protocol, and I'll show you how to run a server. It's open source and stuff. The server, I'm in the middle of migrating from a different API to this API, so maybe some of the examples you'll see in the repositories are a bit inconsistent, but you imagine you do a HTTP GET request, which contains the digest, all of it. It has these folders because you don't want to sort of like just have billions of files in a single folder if you were serving this statically. And what you get back is some JSON with some metadata. The metadata has stuff like the size of the blob that you're going to fetch. The content type is just is nice to have. All the other digests, like maybe SHA-256, SHA-512, SHA-1, SHA-3, whatever. It has more than this, of course. And then the important part, you have a bunch of mirrors. The mirrors are just places in which that binary has been seen before over the internet. And there's also a hint whether each mirror is compliant with CORS or not. So if you're fetching it from a browser, you know whether it's going to work or not. That's basically it. It's just a standard, like this is the standard more or less. It's specified in the repository. If you think about it, it's pretty useful already. In addition to the server, I also have a command line client, which looks pretty much like this. And you give it the thing you want to fetch and where you want to save it. And basically what it's going to do is going to go and fetch these mirrors. And I have an example here. There's maybe 2 mirrors in this example, and it goes through both of them. And the important thing is really it must check that the consistency is correct, or whatever it goes and fetch. It doesn't just blindly download stuff from this mirror. So in this example, it gets 2 mirrors, it goes to the first one, and the first one doesn't match. So it just keeps going, goes to the second, and then the one matches. So, and then eventually you get the file, which is a PDF in this case. So pretty simple. And the command line tool is written in Go, and you will see that there's a lot of integrations I would like to do with a lot of the great stuff that you all here are working on. So end servers are untrusted, which is good. You don't want to have to trust such a server. The point is that if you are a client, then you rely on end. You have to verify the digest locally before you actually accept any content from any of the mirrors. They are lightweight because they only store metadata, really just the JSON for each digest that I show you. It stores the JSON, it needs to serve the JSON. So the storage and the bandwidth, that's very, very cheap. It doesn't store the actual data. It can be run statically. Now it doesn't work quite like that at the moment if you go and download it, but it does. It will support static serving soon, inspired by Tessera and Sunlight, of course. And anyone can run one. Although I don't really envision that would be a ton of these servers. You can think of these like DNS servers. Like you're not going to run your own DNS servers, right? You're going to have a few of them out there that are good to use, and you're going to use one of those, and probably we need to have a few of them, but not one, but like not 1 million probably. So actually, there's a couple of instances here. One is the first one is just a GitHub repository, which is basically just statically serving an index, which is work in progress because I'm changing the API. And another one is this website called static.space, and yes, .space is a TLD, which is pretty cool. So this is the server that I run for public good. It's very cheap to run because, as I say, it doesn't really cost much to serve these little bits of JSON as a web UI. You can try now. If you go open your browser, you type static.space, you actually go to this website. Please don't break it. You can think of it really almost as a URL shortener, except it makes the URLs longer because the URLs are pretty long. So you can actually stick a URL of some file that you have in your S3 bucket or wherever. You can put it literally in the search box, and it will index it, and it will give you a URL with the digest, and then you can send the URL to anyone. And really, what it does, it's a pretty easy way of preventing split views across time and also across clients. If I send you a link to anything, going back to the analogy with the location addressability, if I send you a link to like a Wikipedia article or a file or a PDF or whatever, first of all, there's no guarantee that you're going to see the same file that I'm seeing. It could be a completely different file, or maybe over time the file disappears and all the analogies about before. So we found that this is pretty useful when referencing things like manuals or papers, or like if you have a tweet and you want to refer to something, you want to make sure that everyone has the same view of the thing that you're referring to. If you're endorsing an article or something, having the digest in the URL, it actually does the trick. Or you have a repository and you want to point to a very large file, but without adding into your repository, you can use it the way. And they basically, as philosophically, I think there is an interesting analogy. I think Hayden talked about package managers and so on. There's a cool sort of separation here. You can think of a lot of these things here as sort of like mutable pointers, and you can think of a package manager basically mapping the name of a package and name and version to a digest, and then you can completely separate the storage. Once you know that like a version 0.1 of some crypto library, whatever, resolves to a digest, then where you get the blob corresponding to the digest is completely different problem. There's no reason to mix them together as they are in most package managers today. So this sort of gives you a nice way of separating the mutable pointers from the immutable data. So a bunch of future work. If you take a look, a bunch of stuff is broken, but I would encourage you to let me know if it sounds like something that would be useful to you. And if you want to play around, it's very simple to run a server and also a command line tool. And I give you the link to the static space as the web UI. Take a look around. Thanks for the feedback, and thank you.
Am I on? Super speedy. Any questions for Tiziano? Go on.
Dinner.
So I was wondering about the way this thing gets populated with data. And you mentioned it can happen by someone entering your website and they type in the stuff. Could it be populated in other ways as well?
Yeah. So now it's pretty manual. You can go there. There is also an API actually. So if you have like 1,000 files, you can do HTTP requests to my server, and it's just gonna scan each of them and populate it there. I'm thinking of other ways as well. Maybe you have a trigger on your GitHub GitHub Actions pipeline that for everything you publish, you sort of just trivially is going to call into it. I'm trying to convince people from GitHub to maybe do this automatically in some ways. But yeah, so far it's pretty manual. There's an API. You can mix and match. But let me know if you have ideas or you want to use it for something else. The API is not batch, but you have to call it once per item. But so maybe a batch API would help some use cases.
Yes, thank you for the talk. I'm going to come after you after the talk because I think we are building the same thing. I'm
surprised no one has built it, actually.
Yeah, me too. One problem is I think the thing is useful if the index is built by someone and who may build a very large index of that and who will certify that the mirrors are not spam, for example.
Yeah, I mean, as I mentioned earlier, I'm really keen of the fact that the survey is untrusted, so I don't want to have to trust it. The point is, of course, you would accept some level of spam in the mirror, so that's why for the client it's important to check. That's why even in the hints, in the metadata, I have the expected size, so that if you get a malicious mirror, then instead of sending you back like the 10 kilobyte file, it sends you like a 10 gigabyte file. You're gonna just truncate it and just not even bother with it and just go to the next mirror. So there's some heuristics you can apply to limit the spam. And then as the operator of the index, if you detect that one link is spam, you can just remove it, of course, from the mirror. You don't need to keep serving it forever. But obviously, in some cases, it might be harder, right? Maybe it's the same URL based on the user agent. It resolves differently or in different countries or yeah, whatever. So I don't think it can be eliminated. But I think there are interesting things that we can do to limit the spam. So if you have ideas, by all means, let's talk about it. 1, 2, 1.
Yes. How would you handle a hash collision? I know it's very, very unlikely, but yep. Let's suppose it was possible.
Yeah, I don't do anything special with it, but I do have multiple hash functions. So for each file, I index according to several ones. Now there is a primary one. I don't remember currently if I use SHA-2 512 or SHA-3 512. One of them is the primary one, and the other sort of like points to that one. So in some cases, if there were a hash collision on the SHA-1, as we know that there is, you would notice. Now the API doesn't make it obvious, but you could get multiple entries. And now I'm assuming that one of the hash functions at least doesn't have collisions, which might be falsified at some point. So let me know if you have ideas.
When you access a mirror, and let's assume the mirror is not malicious, but it may or may not have the right version of the data.
Yeah.
Are there any features in the HTTP protocol that lets you ask, I would like to have this file and I expect to have this hash, and if it is unlikely to have that hash, I don't want to download it?
That's a great question. I'm not an expert. I'm sure some people here would know, but there are some caching mechanisms by which you can have e-tags or something and say to the server what you expect to download. And also more specifically, if the target is an S3 bucket, I think there is even more stuff that you can pass in some headers to say exactly what you expect. But I don't think there is something sort of super standard like HTTP standard. But let me know if you know of anything, of course.
Okay, I think we'll leave it there for now. Thank you so much, Tiziano. Let's say thank you again.